Congratulations, you made it so far into your math career that you are now dealing with problems that don't even use real numbers. How crazy is that? Let's look at how we would attack a problem with negative values inside of a square root. So we're trying to simplify a radical with a negative radicand. A radicand is the value we find inside of the square root. So when it's negative, the radicand itself is negative. We need to use what are called imaginary numbers. So let's talk about this problem first, because 25 is a nice number with a square root. It's a perfect square. 40 is not. This is a little bit trickier, but we're going to use this example to help guide us. Okay, so the square root of negative 25 technically can't be done, right? So what does the square root mean? What number times itself would make negative 25? So if we think about this equation here, are there two numbers that have to be the same that could go here and make negative 25? Well, I think we can all imagine 5 is obviously the number we want to use. 5 times 5 makes 25. But we need negative 25. Oh, let's just throw some negatives on it. Negative 5 times negative 5. What's a negative times a negative though? A positive. So there's really no way to make this work. So what we use is the letter I in math. What you would say for the square root of negative 25 is just that it's 5i. Now, why is that? One thing you need to know is that I is standing for imaginary. We're imagining a number that would work. 25 would come from a value of 5, but because the result has to be negative, we just can't make that happen without I. Now, one thing you have to understand about I is, I'll just tell you this rule real quick. I, if I square it, is equal to negative 1. This is a rule in math that we use when we come into situations with negative radicands. So I squared is equal to negative 1. You just need to trust me on that. Now, if that's the case, let's look at 5i and what that means. So 5i multiplied by itself, so 5i squared, well, that would mean 5i times 5i. What's 5 times 5? 25. What's I times I? Well, isn't I times I squared? So that makes a negative 1. So we're multiplying 25 times a negative 1. And what would that give me? Negative 25. Okay, so all we got to do is just attach an I to the part that the negative radicand is for. So what about when we're dealing with a non-perfect square like 40? Well, how would you simplify a non-perfect square like 20? We just split it up into two square roots. We'd say, what are two values that multiply together to make 20? One of them is going to have to be a perfect square. So let's use 4 and 5. Because 4 times 5 makes 20, but the square root of 4, that's just 2. So we end up with 2 root 5, and we've simplified this radical. We're going to do that same idea over here, but this negative comes into play with what we just talked about over there. So what do? We split negative 40 into two numbers that multiply together to make it. You might want to list out your perfect squares over here, 4, 9, 16, 25. Look at your list and ask yourself, out of these perfect squares, which one is negative 40 divisible by? In this case, it's going to be the 4. So we're going to put a negative on the 4 because the 4 is the perfect square. Always put the negative on the value that is the perfect square. And then 4 times 10 is what would give you 40. So we get this. Now what I have to do is I have to take the square root of negative 4, and I can't just say 2 because it's a negative. I need to include I on it. So 2i root 10 would be our final result when simplifying the square root of negative 40. So negative values, you're going to have an I within your answers if the negative value is in a square root. This is simplifying radicals with negative radicands. Hopefully this makes sense. Study hard and good luck on your upcoming test.